NEC section 408.54 addresses the limitations on overcurrent devices connected to a single busbar or conductor. The core principle outlined in this section is that the total combined continuous ampere rating of all overcurrent devices connected to a single busbar or conductor must not exceed the ampacity of that busbar or conductor. This provision is critical for ensuring the safe and reliable operation of electrical systems. It prevents overloading of the busbar or conductor, which could lead to overheating, insulation damage, and potentially electrical fires. Understanding the practical implications of NEC section 408.54 is essential for electrical engineers, contractors, and anyone involved in the design and installation of electrical systems. The ampacity of a conductor or busbar refers to its current carrying capacity, which is the maximum amount of continuous current it can safely handle without exceeding its temperature rating. This rating is determined by factors such as the material of the conductor or busbar, its size, and the surrounding environmental conditions, including ambient temperature and the presence of insulation. Overcurrent devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current flow. They interrupt the circuit when the current exceeds a predetermined level, preventing damage to equipment and reducing the risk of electrical hazards. When multiple overcurrent devices are connected to a single busbar or conductor, the combined continuous ampere rating of these devices must be considered. The total combined rating represents the maximum potential current that could flow through the busbar or conductor if all the overcurrent devices were to operate at their rated current simultaneously. According to NEC section 408.54a, this total combined rating cannot exceed the ampacity of the busbar or conductor. For example, consider a scenario where a busbar has an ampacity of 4000 amps. If you intend to connect 6 circuit breakers to this busbar, each with a continuous ampere rating of 800 amps, the total combined rating would be 6 multiplied by 800 amps, which equals 4800 amps. In this case, the total combined rating of 4800 amps exceeds the ampacity of the busbar, which is 4000 amps. Therefore, this configuration would violate NEC section 408.54a, and you would not be allowed to install these 6 800 amp circuit breakers on this 4000 amp busbar. The purpose of this rule is to prevent overloading the busbar, which could lead to overheating and potential failure. Overloading can occur when the current flowing through the busbar exceeds its ampacity for an extended period. This can cause the busbar to heat up, potentially damaging its insulation and reducing its lifespan. In extreme cases, overloading can even lead to electrical fires. To comply with NEC section 408.54a, you have several options. Firstly, you could reduce the size or number of overcurrent devices connected to the busbar. Secondly, you could increase the ampacity of the busbar. Thirdly, you could use a combination of both methods. Reducing the size of the overcurrent devices means using breakers with lower ampere ratings. For example, instead of using 6 800 amp breakers, you could use 6 600 amp breakers. In this case, the total combined rating would be 6 multiplied by 600 amps, which equals 3600 amps. This would be below the ampacity of the 4000 amp busbar and would comply with NEC section 408.54a. Alternatively, you could reduce the number of overcurrent devices connected to the busbar. For example, instead of using 6 breakers, you could use 5. In this case, the total combined rating would be 5 multiplied by 800 amps, which equals 4000 amps. This would be equal to the ampacity of the busbar and would also comply with NEC section 408.54a. Increasing the ampacity of the busbar involves replacing the existing busbar with one that has a higher current carrying capacity. This might involve using a larger busbar made of a more conductive material. The specific requirements for busbar ampacity are detailed in other sections of the NEC and in relevant product standards. It's important to consult these resources to ensure that the replacement busbar is properly sized and rated for the intended application. In some cases, a combination of both methods may be the most practical solution. For example, you might reduce the size of some of the overcurrent devices while also increasing the ampacity of the busbar. This approach can provide a balance between cost and performance, allowing you to meet the requirements of NEC Section 408.54 without making drastic changes to the electrical system. It's important to note that NEC Section 408.54 applies specifically to the total combined continuous ampere rating of overcurrent devices. The term continuous refers to a load that is expected to operate for 3 IOs or more. If the load is not continuous, meaning it operates for less than 3 IOs, you may be able to apply a different set of rules and calculations, which could potentially allow for a higher total combined rating of overcurrent devices. However, it's crucial to carefully evaluate the load characteristics and consult the relevant sections of the NEC to ensure that the installation complies with all applicable requirements. Furthermore, it's important to consider the directing factors that may apply to conductors and busbars. Directing factors are adjustments to the ampacity of a conductor or busbar that are required under certain conditions, such as high ambient temperatures or the presence of multiple conductors in a raceway. These directing factors can significantly reduce the allowable current carrying capacity of the conductor or busbar, which must be taken into account when determining the total combined rating of overcurrent devices. For example, if a conductor has a nominal ampacity of 100 amps, but a directing factor of 0.8 is applied due to high ambient temperature, the adjusted ampacity would be 80 amps. In this case, the total combined rating of overcurrent devices connected to this conductor cannot exceed 80 amps. It's also important to consider the specific requirements for overcurrent protection of equipment. Certain types of equipment, such as motors and transformers, have specific overcurrent protection requirements that may differ from the general requirements outlined in NEC Section 408.54a. These requirements are typically found in the equipment's listing and labeling information, as well as in other sections of the NEC. In summary, NEC Section 408.54 is a crucial provision for ensuring the safe and reliable operation of electrical systems. It prevents overloading of busbars and conductors by limiting the total combined continuous ampere rating of overcurrent devices connected to them. To comply with this rule, you may need to reduce the size or number of overcurrent devices, increase the ampacity of the busbar or conductor, or use a combination of both methods. Additionally, it's important to consider directing factors and the specific overcurrent protection requirements for equipment. Always consult the latest edition of the NEC and seek guidance from a qualified electrical engineer or contractor to ensure that your electrical installations comply with all applicable requirements. Understanding this code requirement is critical for anyone involved in electrical design, installation, or maintenance. By adhering to these guidelines, you contribute to a safer and more reliable electrical infrastructure. Remember to always consult with a qualified electrician or electrical engineer when designing or modifying electrical systems to ensure compliance with all applicable codes and standards.